Hey everybody, and thanks for listening to this lecture from CyberMD. Today we will be discussing the myocardial action potential for the USMLE Step 1 exam. The myocardial action potential is the electrical activity that occurs in the heart muscle cells, or myocytes. This process is essential for the proper contraction and relaxation of the heart, which in turn is crucial for the circulation of blood throughout the body. The myocardial action potential can be divided into 5 phases. Phases 0, 1, 2, 3, and 4. Each phase is characterized by specific changes in the electrical and chemical properties of the cell, as well as the movement of certain ions across the cell membrane. Phase 0, also known as depolarization, is the initial rapid depolarization of the cell membrane, characterized by an upstroke on the graph of membrane potential. This is caused by a rapid influx of positively charged ions, primarily sodium ions, through voltage-gated channels. This influx of ions causes the membrane potential to become more positive. It is important to note that the trigger for these voltage-gated sodium channels is a change in membrane potential that occurs due to the myocardial cell's connection to pacemaker cells, covered in another lecture, in the heart via gap junctions. Phase 1, also known as the early repolarization, is a slow repolarization of the cell membrane. During this phase, the voltage-gated sodium channels close, and positively charged potassium ions leave the cell via voltage-gated potassium channels. The efflux of these positively charged ions reduces the membrane potential slightly. Phase 2, also known as the Plateau phase, is a period of prolonged depolarization. During this phase, the influx of calcium ions through voltage-gated calcium channels begins, which allows the cell to maintain its depolarized state as positively charged calcium ions enter the cell while positively charged potassium ions continue to leave. The calcium ions that are entering the cell also trigger the release of additional calcium ions from the sarcoplasmic reticulum. This is known as calcium-induced calcium release, which causes the muscle fibers to contract via excitation-contraction coupling. In phase 3, which is known as the rapid repolarization phase, the cell membrane returns to its resting state. This is caused by the large efflux of positively charged potassium ions out of the cell through slow voltage-gated channels, as well as the closure of the previously opened calcium channels. Phase 4, known as the resting state, is the period of time between action potentials when the cell is at its resting potential. During this phase, the cell is ready to respond to a new stimulus and begin the process of depolarization again. In this phase, there is high permeability of the cell membrane to potassium ions through potassium channels, which allows for maintenance and balance of the resting membrane potential. It is really important to note the difference between cardiac and skeletal muscle contractions, which is listed on the available slides briefly but will not be covered in detail at this time. In conclusion, the myocardial action potential is a complex process that is crucial for the proper functioning of the heart. The movement of ions across the cell membrane during each phase of the action potential is essential for the depolarization, repolarization, and contraction of the heart muscle. Understanding the details of the myocardial action potential is important for understanding the underlying mechanisms of cardiac physiology, pathophysiology, and pharmacology. Thanks for tuning in, and be sure to subscribe to our content.